All right, let's finish this up. We have two problems left. Both of them are kind of complicated. You kind of see that these problems take a little while to work. We're going to start with letter C. In letter C, we actually have three vectors that we're going to be adding together. This is going to be as hard as it gets, okay? So we have vector T that has a magnitude of 12 and a direction 80 degrees. Let's go ahead and sketch this out here. So this one's going to be a really steep vector with a angle of 80 degrees. And then we have vector U, which magnitude 16, direction 0 degrees. That means that this vector is actually just going to be horizontal. Okay, about as long as the first vector, but perfectly horizontal. And lastly, we have vector V, magnitude 8 and direction 64 degrees. So that's going to go up here somewhere. I'm just going to let it overlap the other problem here, but it's going to be up here. And we need to find the resultant from the beginning of the first to the head of the last for all of these vectors. Okay, so how are we going to do that? I'm going to try to do it without making triangles, although I encourage you, if it helps you, to actually make the triangles as you go along if needed. Eventually, you should get to a point where you don't actually have to make the triangles anymore, but I'm just telling you, it helps. It helps to visualize things if you feel like it's hard to figure out what you're doing without them. All right, so for the first vector, we need to find the horizontal and the vertical. The horizontal is going to be the magnitude times the cosine of 80 degrees. Okay, so that's going to be my x component of vector t. That's what we're going to call it, x of vector t. There we go. Let me just put an equal sign there. Then we're going to do right next to it. What about the y for vector for t? The y is going to be very similar. It's just instead of the cosine, we're going to use the sine. Okay? Maybe you noticed that in the previous problems that all we did differently to calculate the vertical was we used the same values, we just plugged in the sine instead of the cosine. We're going to do the same thing for the other vectors as well. So I'm going to do some copy paste here. Now, for the second vector, we could do this. We could do x sub, let's see, the second vector was u, okay? So I could set it up like this so that I have 16 times the cosine of 0 and 16 times the sine of 0. This works. But I know that the cosine of 0 degrees is actually 1. Okay, maybe you remember that from a previous investigation. And the sine of 0 degrees is actually 0, which makes this whole thing 0. And wouldn't that be what you expect for a 0 degree vector that goes horizontal? What's the y component of this horizontal vector? It's 0. What's the x component? Well, the entire length is x component for this vector. And that's our second vector, okay? So we're only going to worry about the y component of that, or the x component of that vector, because the y component is 0. And then we're going to do our third vector. So the second one was really easy. The third one is back to normal here. And we're going to plug in, let's see, what is this one? V, vector V. Okay. So let's do that. And then it's going to be, let's see, not 12. The last one is 8 times the cosine of 64. And then in the y, it's going to be 8 times the sine of 64. And now we're ready to actually start doing some calculating. So we do 12 cosine of 80 and 12 sine of 80 first. So we'll go back to our calculator. 12 times the cosine of 80 degrees gives me 2.08. We'll just plug in the whole thing. So this, I'm just going to plug in 2.08. Okay. And then our y is going to be 12 times the sine of 80. So we'll plug that in. 12 times the sine of 80 degrees. And I find that that's 11.82. So we're going to plug in 11.82 for that y value. Okay, we got our second vector already done. Our third vector, 8 times the cosine of 64. 8 times the cosine of 64 is 3.51. So we're going to plug that in here. Now, this is the part that takes some time because we got to evaluate all of these different trigonometric expressions. 8 times the sine of 64. All right, and then we get 7.19 for that. We're going to plug that in. Now we can add our components. Okay, so we're going to start 2.08 plus 3.51 plus 16. Might be able to even do this one without a calculator. So this is the x component of the resultant is going to be the sum of all of these other values. It's going to be let's see, 0.59 is going to be 5.59 plus 16, 21.59. And the y component of the resultant is going to be these ones added together. This is going to be a little more complicated to add here. Let's see. I know that 0.82 plus 0.19 is almost exactly 1. It's 1.01. So that makes this 8.01, 19.01. This is just going to be 19.01. So my resultant is going to have a total x from here all the way over to here of 21.59 and a total y from here up to here of 19.01. If I were to go ahead and just make the triangle that looks like that, just so I can visualize this one, because it's important to be able to visualize. The triangle that this vector makes would look sort of like this. I'm just trying to put it out of the way here somewhere. Sort of like this, where the bottom of it is 21.59. This side is 19.01. I need to find the magnitude and angle of their sum. Well, the magnitude is going to be Pythagorean theorem with x squared plus y squared, and I need to take the square root. So it's 21.59 squared. Let's just plug that in. 0.5. Let's start the square root of 21.59 squared plus, and then what was my other one? It was 19.01 squared. Okay. 28.77 is the actual magnitude of the resultant. Once again, that was 28.77. And then the direction is going to be, just like before, the inverse tangent of opposite over adjacent. So it's going to be the inverse tangent of the opposite side is the y side, because I'm looking over here on the triangle, and this is the angle I know, so, or I'm looking for down here. So I'm looking for this 19.01 over the adjacent 21.59. 19.01 over 21.59. Let's plug that in. Inverse tangent of 19.01 over 21.59. We get an angle of 41.36 degrees. 41.36. All right, and let's see if we did that right. Oh, I'm a little bit on pins and needles here. 28.77, 41 degrees. We did it. All right, and then on to the last one, the easy one. Letter D actually is just two components of a single vector resultant. It says that a pull for a tent makes an 86-degree angle with the ground. If the load on the pull is 25 pounds, what are the vertical and horizontal loads? All right, so let's just take this guy here. This is almost a vertical vector. It's almost a vertical. I'm going to exaggerate the angle of this vector just to make it fit here. And we know that the load on this vector is 26 pounds, 25 pounds. I'm going to make this vector pointing upward like this still. So normally loads pull downward, but I'm just going to make this represent the amount of force with which this vector has to push back on the load to hold it up. This angle down here is 86 degrees. And I need to decompose this into the x and y components of this. And we've seen enough of these that you know this is actually not going to be that hard. Because what are we going to do? Well, it's just going to be 25 times the cosine of 86 gives me the horizontal load. And that's really easy to calculate. 25 times the cosine of 86. I just go to my calculator, 25 times the cosine of 86 degrees. The horizontal load is 1.74 pounds. So this pole is having to push 1.74 pounds to the right. And then I'm going to do 25 times the sine of 86 degrees to get the vertical load. All I have to do is plug that into my calculator and I'm done. 25 times the sine of 86 degrees. 24.94. 24.94 pounds up. Okay, this is my horizontal, so I'm going to note it as horizontal by saying that's the x component. X equals, and if it was easy for me to do here, I'd put a little vector label over it because the x component vector is 1.74. The y component vector, the vertical, is 24.94. Let's just check our work on those ones. Vertical 24.94, horizontal 1.74. That's how you work these. You're changing vectors into right triangles, and you're using sine, cosine, tangent, inverse sine, inverse cosine, inverse tangent, and also the Pythagorean theorem to solve these. You are ready to do the problem set for next time.